All right. So, I didn't plan this at all, but I wanted to talk about the concept of quantum relativity. I'm not sure if it's been posited before, but a relative perspective in quantum thermodynamics here is such that because of the different ways information can be passed through a dimensionality type string theory physics, but also because of the way different things can be knowing of, meaning the particle or duality of the particle itself, knows that it itself is what it is, okay? But it, upon collapsing, is, from our relative perspective, going to be this one and only one type of thing, okay? Which is a quantum relativity. It's like, oh, you're experiencing a type of, relative to us, gravity that is, the equivalent of our Earth's gravity, accelerationally speaking. But, it's a similar concept of, for it, relative to our perspective and what our knowledge is able to gain and glean from what they're doing or not doing, meaning particles, atoms, fields, even light has its own version. There's a lot of different, superpositional or quantum wave function variability that means we don't know what it is. But the fact of the matter is something in a different relative perspective to our version of events can absolutely 100% know that it's this. And this is what's going on with it, okay? We're just in the perspective of we don't know, and it is an unknown, statistically speaking, until we collapse it, otherwise known as detect it, otherwise known as just destroy its ability to not have privacy. It's effectively what it views itself as, from my relative perspective. It's like the quantum particle has privacy, and uncertainty is then formed as a result of this privacy. You don't know because it hasn't told you what it is that it is doing, thinking, interacting with, and so on. Just like your children when they're teens and you don't know what the hell they were up to last night. Same thing. Same thing. That is quantum relativity and quantum thermodynamics, okay? Quantum physics is a part of quantum thermodynamics. It just is. I don't care really what people fucking think. It is. Quantum thermodynamics is a real thing. It is being built upon mathematically and through experimental means, and in fact, based upon the Heisenberg uncertainty principle here, which is not being violated in any way. It's a relative perspective. It's not violated. We know what it was, or what it is going to be. I say was because time-wise, we learned what it was, and then we got the information, and now we had it. It was known in the moment, at the now point. It was known. For us to be able to know. For other things, which are not hidden variables, we're talking fields, we're talking other things that we are not using to detect in its small little fast-moving world what it is, and what it is that is going on. Because, of course, they're able to still glean information upon their interactions. Information is still moving. Information still happens. Otherwise, interactions would never occur. Okay? Fields that are around are still going to be interacted with. Other particles are still going to be there. Even if we don't know in the weirdism that is the Bell's fucking whatever the garbage it is, as far as I'm concerned, it's a shit in every way experiment. It's still touching fiber optic lines. It's still interacting with fucking fields. In every way, they know what the hell was there, even if we didn't. That's the literal definition of you proved me right. You proved quantum relativity correct. You prove that quantum thermodynamics because the particle didn't just, whoop, I'm gone. Didn't exist. And now you know. The photon was still there in the fiber optic line, idiot. He's literally proving me right. Literally. Yeah! Is what I imagine they'll end up going to. They'll just screech and scream. They're garbage to me. I'm like, you couldn't perceive that, in fact, just because we don't know doesn't mean that people aren't still living their own lives. Particles are still living their own lives, interacting with their own things. Just because you don't know about it doesn't mean it's not happening. You don't know all of the things about all the fields and all the particles, which it bounced around into the various glass apertures of bullshit that are mirroring itself to the fucking final destination point of the detection that gives us a electron variance that says, hey, it was this, actually. Even though everything knew what it was before you did. That's how that works. That's a quantum relativity. It's still, in our perspective, going to be a non-known superposition, not collapsed wave function that hasn't yet interacted in a way for us to be aware of what the hell it's doing and what it is. Quantum relativity. It is a John Tyler Lemke. I am John Tyler. That's my real name. I live in Springerville, Arizona, if you must know. I don't give a shit. Know me. But it's a principle. It's a mathematical-based principle that has already been proven, truthfully. But nobody's ever talked about it, really. The math, I'd just have to fucking string the right ones together. But I'd have to get into all that shit, and I don't really want to do it. So, it's a relativity thing. Because it's relative to our perspective. They are moving. They're not experiencing gravity in any capacity to us. They're not doing that. But they are. Their perspective is they are definitely experiencing gravity. It's a principle that's based upon Heisenberg's uncertainty principle of a perspective value that is like gravity, but it's not gravity. There's no gravity. No gravity. It's an information transfer. Information is not known until it is known, meaning it is uncertain until it is certain. But it is not uncertainty that I am talking about. It is already known to be certainly these things. We just didn't know. Because we didn't interact, because we didn't observe. And so, while other things knew, we didn't. That is the certainty principle. That still means we're uncertain about something until we're certain about it.